Hey social media fans and friends, this is your friendly neighborhood astronomer. I haven't done this in a little while, but since it's the beginning of a nice long holiday weekend, I thought I'd give you a nice little view of the sun, our star in our solar system. We've got some nice sunspots streaming across the visible surface of the sun there, otherwise known as the photosphere. We can zoom in a little bit on these guys and I will play with the focus. The smartphone cameras don't always cooperate, but that's not bad. If you've listened to my videos before and watched them, we talk about what sunspots are. So these are volumes of plasma caught in the sun's magnetic field, so it doesn't get a chance to convect, so it stays a little cooler. It's not really cool, but compared to its surroundings, it is cooler, so it appears darker. They usually appear in pairs because these magnetic bands, kind of like a rubber band, poke through the visible surface, quote unquote, of the sun, the photosphere. That's the part that we could see from Earth. Well, anyway, when they poke through that, they make these pairs of sunspots. Our sun is a pretty average star. It's pretty neat. Stars that are a little bit larger, well, they can have a lot more activity. They can have a lot stronger magnetic fields. I'm going to compete with this airplane flying overhead right now. But in any case, our sun is basically a giant ball of hydrogen and to a lesser extent helium. And the hydrogen's getting fused in the core of the sun. That's what gives the sun its power, its energy. It's all the energy liberated from that fusion process in the core. That energy radiates out from the core in something imaginatively called the radiative zone. And then it gets into the convective zone. And then eventually it makes its way up to the visible layer of the sun, the photosphere that we can see. Now above that is the chromosphere and the solar corona. Those are things that we can see. Well, the chromosphere is what we can see with a hydrogen alpha telescope, and the corona is what we can see during a total solar eclipse. So very cool stuff. Now when stars are larger than the sun, up to about 8 to 20 solar masses, or times the mass of the sun, when they burn through all their hydrogen, they get to later stages of their lives. Again, competing with another plane. I don't know what the deal is today. They wait for me to get out here. Anyway, as they start burning heavier and heavier elemental fuel up the proton-proton chain, up the periodic chart, they burn hydrogen and then helium and probably like lithium and beryllium and all the other intermediate, oxygen and nitrogen, things like that. And then eventually they'll start to burn silicon. Now, when a very large star, let's say something about 8 solar masses or so, between 8 and 20, starts to burn silicon, if you want to consider that the beginning of the supernova process, or the process leading into a supernova, what happens is it takes billions of years maybe to burn through all their hydrogen, and then helium takes less time, and then the other heavier elements take less and less time, to the point where it burns its silicon in about a day. And then when that is done, the actual supernova collapse, what happens is this silicon is burning into heavier elements, including iron. When it burns into iron, when it fuses into iron, that process, anything iron and heavier, doesn't give off more energy than it takes through that fusion process. So there's no force pushing out against gravity pulling the star in. So when that happens, it takes less than a second, and it's this stuff, the outer layers of the star are falling inward at a very high fraction, or a significant fraction, of the speed of light. So a large star can collapse into a supernova in less than a second. Once it's done burning silicon and it's burning iron, there's no more force pushing out against the star. So just a little fun fact there. Hey, if you want to learn more, you can join my class. My past and future students would do well to check out Phil Platt's Crash Course Astronomy on YouTube, and lots of other resources out there. But come to class, we can talk about all this kind of stuff. I teach class in here in Westchester, do lots of outreach with Chicago Astronomers, Chicago Astronomical Society, Chi-Town Stargazers, and other groups. In any case, come and join us. Learn more about astronomy and the sky, both night and day, and just develop a love of nature and astronomy. You can't go wrong. You'll get so much out of it, and I hope that you come out and join us and become part of our astronomy community. Thanks for listening and checking me out. This is the Friendly Neighborhood Astronomer signing off.